All right, we're on 56 of our packet. We're talking about sine, cosine, and tangent today. So a lot of you have probably seen on your calculators these little keys that you've never used, maybe have used before, and it's sine, cosine, and tangent right there. Sine, cosine, tangent. And right above it is the sign with the little -1. That's the inverse of the sine, or the opposite. The inverse of cosine, inverse of tangent. That's about as deep as we're going to go. We're not getting into the heavy trig part. But we are going to talk about ratios today. So I don't know that we're going to be using these keys as much today as talking about the setup. But that's what these keys are for. And it says SIN, but it's really pronounced sine. And cos is really for cosine, and tan is for tangent. So let's talk about these different ideas. In the warm-up, it says write the ratio of the smaller leg to the larger leg following the right triangle. Now notice this is again a right triangle. So these are my legs, and this is my hypotenuse. So it says write the ratio, so it'd be 6 to 8, like that, which is the same as 3 to 4. So you can write a ratio like this, or as a fraction, 6 over 8, which equals 3 over 4. And we're really going to be working in the world of fractions. Okay, so that's our ratio. We did short leg to long leg. Now, this is the same idea that we did before. We have our right triangles, we have a short leg, a long leg, we have our hypotenuse. The difference is we're not talking about the special right triangles. Before we had the 45, 45, so these were equal, and then we had the 30, 60, 90. These are not special right triangles, so I can't solve them without using sine, cosine, and tangent. The special right triangles had that quick relationship, so we didn't have to do extra work. We just had to multiply or divide by the square root of 2 and a couple rules for these. So this is how you would do any right triangle. All right, so we use the ratios of right triangle for trigonometry. The word trigonometry comes from two terms that mean triangle and measure. Trig, and then your metry in there. Okay, if we have a right triangle, one angle must be a right angle. So here's my right angle for my right triangle. And it says we could label one of the other angles theta. Theta, that's what this is. Theta, part of the Greek alphabet, and it really stands for the measure of our angle, but you could use any variable for it, anything like that. The other thing I want to remind you of, if this is capital C for the vertex, the opposite side is considered lowercase c. Capital A, its opposite side is lowercase a. Capital B, it's lowercase b for the side. So if I tell you triangle ABC and side B is 5 units, this is angle B, side B would be opposite. So I don't have to name it AC, I know it's B. So do we see the idea of opposite sides? Okay. Now, we do have to think about this, about the sides of a triangle. One side is the hypotenuse, we talked about that, and the other two are called the opposite and adjacent. Now, we do call them legs, but we're going to verify opposite and adjacent sides. Now, you can change which one's opposite, which one's adjacent by which angle we're looking at. So, first things first, it says label the opposite side, adjacent, and hypotenuse of the following triangles. Guys, this is my 90-degree angle. So that doesn't count for anything. But if this is the angle I'm focusing on, theta, then this side is adjacent because it's touching the angle. It's right beside it. Adjacent meaning like this, an adjacent building side by side. This side is the opposite because it's not touching it. Just like I said, if this was capital B, this side is opposite, it's lowercase b. This will always be my hypotenuse. That is not changing. So 90-degree angle, whatever side is touching is adjacent. So adjacent is the side touching or right beside it. Opposite side is the one not touching the angle. Not touching, I'm going to put theta in here, not or touching theta. There you go. Hypotenuse is always opposite 90-degree angle. I think one of the things that drives me crazy is when we're into this and I still don't have students that can label opposite and adjacent. So here's theta, and we're paying attention to this, and our phones are gone. Here's theta. This side is touching theta, so it is considered adjacent. This side is opposite, so it's considered opposite. See how it's not touching? The two sides that form this, these two that come out and form this, that makes the opposite side. This is always by no choice the hypotenuse. Now we could also flip this around any way we want. We would have the same thing. So if I drew a triangle like this, and we were talking about this side right here, then this is your adjacent and this is your opposite. And a lot of times I just label it like that, so I'm not writing out the whole word. This one is still your hypotenuse. All right, you need to be able to figure out which one's opposite and adjacent because everything's based on that. Once you know that, it's pretty much just plugging it in. Okay, so here come the trig ratios. And you have this on your other sheet. The abbreviation of sine of tangent, instead of writing that whole thing out, is, it looks like sin and then there. Oh, sorry to theta. So sine theta, that's it. Cosine we call cos theta. Tangent is tan theta. So instead of writing out the whole word tangent of theta, we just write tan theta, cosine theta, sine theta. All right, now what's the value? Well, sine of theta is equal to the opposite side over the hypotenuse. Now you don't have to spell that out. You could abbreviate to save yourself time. The idea, when I look at my right triangle, to find the value of the missing angle, I use the sine theta and I take the opposite side over the hypotenuse. So I'm just plugging numbers in. The cosine of theta is the adjacent side over the hypotenuse. So all of this depends on where your angle is marked. And then tangent is the one that's a little bit different, and that is opposite over adjacent. Now, a lot of you will just memorize these because you use them so much. There's a quick little memorization tool called SOA Katoa. So when you come up to me and you're like, I don't know how to do this, you might hear me say SOA Katoa. Well, the SOA stands for sine opposite over hypotenuse. Do you see the first letters there? And COA stands for use cosine. It goes with adjacent and hypotenuse. And tangent with opposite and adjacent. So it's really the first initials of everything. Now, if you look at your sheet that I gave you, we're only focusing in this top piece today. If you have a right triangle, that's the SOA Katoa. See, it's the exact same thing. Sine is opposite adjacent. SOH, SOA. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So if I'm using my right triangle trig, I either need to know two sides, I can find an angle, or I need to know the angle on one side, I can find the third side. So I don't have the whole triangle. Okay, the other saying is some old horse came a hopping through our attic. Some old horse came a hopping through our attic. It's pretty random, but that's just as random as please excuse my dear Aunt Sally, isn't it? So I am not asking you guys to memorize these. So you'll have access to the sheet, but some of you will have it memorized anyway. Down here, law of sines, law of cosines, we're going to get to that later, but we are just focusing on using our right triangle trig. This is if I don't have a right triangle, then I have to use some other rules. Okay, so now that we know about SOA Katoa, what we would do to solve these. We want to label the sides in relation to the angle. So I'm talking about which one's adjacent, which one's opposite, which one's hypotenuse. No reason to come up to us and not have your triangles labeled. Find any missing sides using Pythagorean Theorem. Oh, so if there's something I could do, I would use Pythagorean Theorem, which is a squared plus b squared equals c squared. Now remember, a and b have to be the legs. C is the hypotenuse. Okay? And it says use the ratio SOA Katoa to find the measure of the trig function. So that's what we're doing, sine, cosine, tangent. Okay, so let's try one. It says here, using the given right triangle, and I'm going to remind you, it has to be a right triangle to use sine, cosine, or tangent. It says find the value of sine, cosine, and tangent. So we're going to do all three of these. Now, first things first, this is my angle. So this is definitely my hypotenuse, opposite the 90 degrees. This is my angle I'm focusing on. So it's whatever they told you the angle is. This is my focus angle. This is my adjacent. And then this side doesn't touch it. This is my opposite. So I do have a problem. I don't know the adjacent side, and I don't know the angle. So what I'm going to do is use Pythagorean Theorem. And I'm going to do 3 squared plus b squared equals c squared. So that's why we practice that. So that would be 9 plus b squared equals 25. And you definitely need a calculator when we get into this more. I can do this without a calculator. B squared equals 16. So b equals 4. Okay, perfect. So now I know all three sides. Now, we are just practicing our ratios. We're not actually solving or using anything right now. So sine of theta is equal to, and if you look at your sheet, let's just keep the sheet right here with us. Sine of theta is equal to hypotenuse over, or opposite over hypotenuse. So my opposite side is 3, my hypotenuse is 5. And that's it. Now, if they ask me for a fraction, I'm going to leave it like that. If they ask me for a decimal, I would divide it. So there's my sine of theta. Now, cosine of theta. Cosine was adjacent over hypotenuse. So the adjacent side is 4. The hypotenuse is 5. That's it. Tangent of theta. The tangent is the opposite over adjacent. So my opposite side is 3, my adjacent side is 4. So again, we are just practicing the trig ratios. You would not do all of this work. You would just pick one thing that you have and use that information, and we could find the angle. And that's another step. So these are the ratios. That's all they wanted you to do. The value of sine theta is 3/5, 4/5, 3/4. You need to make sure you always reduce your fractions. Okay, so next problem. Let's go ahead and look at this. It says, given the right triangle ABC, find the value of sine A, cosine A, tangent A, and then go back and do sine B, cosine B, tangent B. Okay, so what are they talking about? If we focus on A, this is like my theta. So I want to find the value of sine A, cosine A, and tangent A. Then I'm going to switch paces, and I'm going to ignore this and focus on B. So I think I'm going to redraw my triangle real quick. Doesn't look the exact same, but that's okay. And then I'm going to refocus on the sine, but of B, cosine of B, and tangent of B. And what would probably help me more is if I actually label this. So this is B down here, A, and C. Okay, so what's so important? Why did I redraw my triangle? Over here, if this is my angle, this is my adjacent, this is my opposite, and this is my hypotenuse. So we want to see those labeled. Now, if I focus on B, this is my focus. Then this now becomes my adjacent, this is my opposite, and this is my hypotenuse. So it changes how the ratios are. So take a minute, use your sheet to help you with your sine, cosine, and tangent, and fill those ratios in. So you should have 6 fractions here. Okay, I have no time left on this recording, so I went ahead and I labeled my adjacent, hypotenuse, opposite, and so you can see that these are my ratios with the reduced fraction there. And then I redrew my figure so I could relabel my adjacent, opposite, hypotenuse. I put these in. The last question is definitely more involved. And if you look at it, it wants all the ratios as a fraction and a decimal. And I am actually missing amount of time. See, I knew it. What time does that say? 14 what? What a